Hi, my name is Jeremy, Associate Research Faculty at Yale University, CEO of Innovative Omics. And today we're going to be discussing how to run FluoroMatch, PolyMatch, LipidMatch modular. So the modular version of our software platforms. Now, these software are modular in the sense that if we run our modular version, we can use any peak table we want. So we can use XCMS peak picking, we could use MZMine peak picking, we could use Compound Discoverer, we could use Agilent Profinder or Explorer, we could use Skyline. So all of these amazing software that the community is building, not only can we use their peak picking, but also any annotations they provide, any curation of the data, defining adducts, whatever work they've put into helping you curate your data set, we can include and then add on top of using our software, and then also have our amazing visualizations using our visualizer to include not only evidence from our data, but if you're good with Power BI, we can also start including some of the evidence from the data processing you've done previously with the other software. So your data set can look pretty much like anything you want. The only thing is that it has to have a mass to charge column, a retention time column. It doesn't have to be in this order. It doesn't have to have these names. It has to have a row ID column. Again, it doesn't have to have this name of the header, but some kind of header row. And the row ID should be numeric. So let's say Compound Discoverer doesn't report identifiers in your table. You can just put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down your sheet and drag down. No problem. So you can just make up identifiers. The other thing is, while in previous versions we may have supported different numbers of headers, in this case we only support a single header. Maybe in the future you can look in the comment sections or note if we have allowed you to have multiple headers. But in this case, just a single header. Other good things you probably want in your sheet, not that they're necessary, is your peak areas, peak intensities. Those can all be helpful things, obviously, to have along. And you could have annotations in any of these columns. Again, the sheet can have as much information as you want, as long as it has retention time, mass to charge, and a row ID. So you may only have negative polarity mode, you may have only positive, or you may have both. In this example, we show both. Then you have your mzML files that you've converted using MS-Convert, or for Agilent you'd use Qual, or for Shimatsu you'd use their vendor file. But however you best can get mzML files, which we've discussed previously in the previous tutorial on file conversion and naming conventions, you want to get those mzMLs, and you want the naming conventions to be correct. So you want, at the very minimum, at least one target file per polarity with target in the name, and then underscore pos or underscore neg. And you also want at least one msms file per polarity as well. And then ideally, if you have blanks, you can include the blanks here, but it's not necessary to include blanks in the modular workflow. And these will just be aligned with your data set, and you can do blank filtering after the fact. Now, in order to run modular, you go to the modular folder. So if you're in FluoroMatch or LipidMatch or PolyMatch, you double-click modular, and then you open up the R code. So if you have RStudio, it might open up in RStudio. If you don't, you can open it up with, for example, a text editor. So let's open that up, and you can download RStudio for free. So here's the code. When we run it, we're going to just press Control-A to highlight everything, and then click Run. Now, there's a couple things we want to check. So CSV input equals true, so you don't have to really edit anything along these parameters. The only thing you need to change is, in this case on line 38, it might change the line, but look where it says CSV inputs, and change this directory to the directory with your CSV inputs. So in our case, this. In our case, we have our data is all in this test modular folder. And if we go into FluoroMatch 5.7 modular, you can see this folder called CSV parameters. You can select that, and that's going to have your parameters file. I don't like to edit that one. The original one, always make copies of any of the files you're using. Don't put it exactly in your same folder, but you could put it, for example, in a folder upstream from your inputs, or have a separate folder for it. So now if we double click our parameters, then we should see all of the parameters available to you. Note that some of these parameters are not used by Modular, so you can ignore them. After this intensity conversion, threshold conversion, so that's for file conversion, which we've already done, right, in Modular, so we've already converted to mzML. You can ignore, so in this case, lines 16 to 24. These are all related to flow, and because flow also uses the parameter class. So ignore all these. You don't need to change these. As far as the other ones go, there's a retention time window. So this is for aligning mzMS scans to your feature table. So for example, in the default of 0.1, it would look plus or minus 0.05 minutes from your feature. So if your feature table is 760 mass charge at 2 minutes, it would look at between 1.95 and 2.05 minutes to see if there's any mzMS scans at mass charge 760. Also using your mass charge tolerance there. Then there's a search tolerance. So this is going to be plus or minus 0.01 Daltons. If you have better resolution instruments like we do with the Agilent Revident, we can go up to plus or minus 0.005 Daltons. We have the mask search window, so this is going to be half. So this would be plus or minus 5 ppm. Isolation window. So this usually is 1 Dalton. And then the minimum scans for a fragment to be confirmed. So let's say, for example, you're using a QTOF and you weren't averaging scans, and you wanted it to require 10 mzMS scans with that fragment for that fragment to be confirmed. You can put that here. Generally, I've never changed this beyond one. One good mzMS fragmentation pattern in any vendor's instrument should be enough. Then your intensity threshold for mzMS. This could be 60, for example, for an Agilent. For Thermo, it might be 1,000. Note that for a lot of these parameters, such as the intensity threshold, they're going to depend on the instrument. And you can actually open up the software, the flow version, which we show in the prior tutorial, and you can select which instrument you have, and they have some pre-filled parameters. Some of these parameters are pre-filled for you, so you could double check if you're not sure what to put here. AIF is only in the case you run all ions or have all ions files. In our example case, we do not, I believe, have all ions files. Let's see. So this is the test modular. Yep, so there is no all ions files, so we can ignore that parameter. But this would be the correlation cutoff, whether a fragment correlates with its precursor ion and is retained as belonging to that precursor ion, and this is the number of scans required for each fragment to be considered real across a peak. In this case, we use more than one scan because all ions is, again, alternatively getting mzMS between full scans, so you should get a lot of mzMS scans across a peak, and so you should be able to acquire more. Plus, you need to correlate the precursor ions to the fragment ions, so if you only had 2 scans, you couldn't correlate them. So it has to be 3 or higher, ideally 5 or higher. These parameters are important, otherwise the code will error. You need to have the row ID, mass charge column, and retention time column, and the row the data starts correct. So again, this will always be 2. As we mentioned, you can only have 1 header. but these can change. So in our case, we open up the feature table again that we got from our other software. So that could have been from, let's see, let's minimize this. All right, so here's the peak area, negative mode data. We see that the row ID is in column 1, mass charge is in column 2, and retention time is column 3. So it starts 1, 2, and then 3. In our case, retention time could be in column 4 or 7. It doesn't matter, but in our case, it was 1, 2, and 3, and the row starts at 2. So we want to make sure we put that. Indeed, it's already set, 1, 2, 3 in our case, and 2 because these are the default build for MZMine outputs. Again, you can ignore these, but the last things you need to change, also very important, or the software will error, is the directory of inputs and the directory of your libraries. The inputs are that folder that contains everything you need. So again, it needs your feature table, and the feature table needs to end in _neg.csv or _pos.csv. So it has to be a comma separated format, and it has to end in _pos or neg, or if we have both, we have both. Then you can have whatever other names you want in that feature table. And then for our mzML files that we can get from MS-convert-qual, etc., same naming conventions we mentioned earlier, but again, you need to have a target and at least a DDMS2 at the very minimum in this folder per polarity. You can have many DDMS2 files per, and you can have many targets, and you can have many samples, and you can have your blanks. So I'm going to copy this directory, right? Because this is the directory of our data. And I'm going to paste that directory in here. And we have to make sure that these are // and that this directory ends in a // So you have to replace each / with a // And then we also need our directory of our libraries. So the libraries are just something that have come with your software, whether it's FluoroMatch, LipidMatch, or PolyMatch. They'll all be in flow, distribution, libraries. So again, we're going to copy this entire directory. We're going to paste it in to the parameters. And we're going to replace the / with // Make sure you don't accidentally do something like this and replace the letter or miss a slash. Otherwise, again, there's going to be errors. All right, so perfect. So here we have our two directories. They won't necessarily go blue. That's a LibreOffice thing. So now I'm going to save this file. You can save it as something else if you wanted to, but keep the same file name, parameters.csv. If I save it as something else, I mean in a different directory. So now in your text editor or wherever you're editing, you want to put in the directory of your parameters file. So in this case, this is the directory, and we're going to put that into our code itself. So the parameters directory is going to be over here. And again, if you haven't gotten used to it yet, make sure to put everything as a / and end in a /. Parameters is already the same. If you change the file name, you would have to change it here as well. So now we can run the code. There's two ways that we can do this to make sure it works. One is you can link your RStudio, if you're using RStudio, to the R version distributed with LipidMatch or FluoroMatch or PolyMatch. That way you make sure that it uses the correct packages and everything that are pre-installed. Otherwise, you can Control-C, copy all of this, and you'll run it in the version of R. So if I, again, go to our software, go to Flow, go to R 4.4 or whatever the R is at that time, X64. Now we can have the R GUI, open it up, and then we can run the software just by pasting it after Control-Alt. and then it should work from there. So that's it as far as, you can click allow here. This is the first time you've run our version. That's it as far as running the modular. And then it will just run. And if it errors, it will produce an error that you'll see, and it won't necessarily finish the run. And if it doesn't error, then there'll be no error messages. Sadly, it uses blue for error messages and prints of what's reporting, but the one way to know that it ran correctly is if you go into your output. So here, now you see that there's a folder called output, and it will start building the outputs in there. But let's look at a project that's already completed. So there would be your output folder. You should get, per polarity, you should get at least these 5 files. So the EICs, MS1, P-formula, MS1 is negraw, MSMS, and neg-IEFIN. If you get those 5 files, then the software likely completed, and you can go to the next step. So this is a way to also check it. Obviously, the Flow has a loading bar, but the modular version does not. As with the modular, as with the Flow, just be patient and let it run. Depending on the number of samples, etc., it might take some time to run.